All right, class, hopefully you found the correct video. This is Algebra 1, Lesson 2.1, and expressions. So just getting started in Chapter 2. And so let's start off with a definition here. So an algebraic expression, algebraic, A-L-G-E-B-R-A-I-C, an algebraic expression. What is an algebraic expression? It's simply a mathematical expression containing numbers, variables, and operational signs. Hey, what is it? You've got some variables, you got some numbers, you got some operations. Addition, subtraction, multiplication, division. So something like this, 3n minus 7. There's an algebraic expression. Not a big deal, just a term. All right, do you remember from last year what to do to evaluate? So when we evaluate, if you remember, we're looking to sub in the values of the variable and solve. So sub in, you can write substitute. Sub is a short term there. Sub in the values of the variable and solve. All right, very important as we talked about last year in this idea of substitution. I tried to teach you guys to put a parentheses everywhere where you see the variable. So if you'll focus your attention right here, notice that there's a negative, then x squared. Where the x is, I have the parentheses. And then you got this minus y, and where the y is, I have the parentheses. That's a simplistic thing, but I'm telling you, it's very, very, very important. And so now I'll go back, and where the x is, in red, I'm going to stick in -5, and I'm going to go back where the y is and stick in -7. All right, from here on out, it's an order of operations problem, and you just need to be careful with minus signs and with exponents. So I need to evaluate this exponent first. I cannot do minus a minus. You would be violating the order of operations if you did so. So you can't deal with this minus the minus because of the squared. You've got to do the squared first. All right, -5 times -5 is 25. So I still have this minus sign. Now I can deal with this minus the minus right here. And that is a plus. And so now I have -25 plus 7. Finish that off for a total of -18. Okay, just be careful with the minuses and be careful with anything squared. All right, so here we've got a problem. It says evaluate 2n minus 7 for each value of the domain 3, 3/4, and 5. Each value of the domain, and they tell you what those values are. If you remember, the domain are the input values. So really what we have is 3 problems in one. It's not a big deal, not a tough problem. We're just doing 3 in 1. So the first time where the n is, so I did 2 parentheses minus 7, right? I'm going to stick in the 3, and I'm going to solve this out. So we end up with 6 minus 7, and that's a -1. All right. Second time, same thing. Where the variable is, I'm going to stick in this time now 3/4. Okay, so not a problem here. We got multiplication. I'm going to arbum. I'm going to reduce before I multiply. And so we know we end up there. So right now I'm at 3/2 minus 7. So you look at that and you say, oh, I'm adding fractions. What do I need to add fractions? I need a, and I hope you're thinking common denominator. All right, let's get a common denominator. What does the denominator need to be? A 2. So let's multiply the bottom by 2. Whatever you do to the bottom, do the same thing at the top. And let's rewrite. So right now we are at 3/2 minus 14/2, right? And we are simply going to add the numerators, put them over that common denominator, and it looks like we end up with -11/2. All right, that's the second value, and then the third is pretty easy. Again, where our variable is, we're going to put in the domain value, and that's a 5. We end up with 10 minus 7, or 3. Okay? So look, if they give you 2 values for the domain, you have 2 problems. If they give you 3, you got 3. If they give you 8, you got 8. And hopefully I won't give you 8. But they're just values of the domain or of the variable. You just work through each one. All right, let's start working on some word phrases. So we got to change the word phrase to an algebraic expression. And we've got a couple simplistic ones. So let's take a look at A here, the sum of a number and 7. All right, if you remember, we want to NTV, right? Do you remember what that stands for? All right, hopefully you're thinking name the variable. In these simplistic ones, it's not that big of a deal, but we'll do it anyhow. And so all you have is the number, and we'll just call it N. N. And then if you recall, now you want to look for keywords. So when you look at the phrase, you see the keyword, the operational word sum, and we all know that that's addition. And then look, what are we summing? A number. What is the number? N. And then N7, and so we end up with N plus 7. Pretty simplistic, not a whole lot there. All right, let's take a look at the second one. 5 less than twice a number. All right, so again, we have the number is our variable, and again, I'm going to call it N. Start looking for operational words, less than. All right, we all know that's minus. Now, students mess this up because the 5 is on the left, and they want to put the 5 on the left of that minus sign. But let me ask you a simple question. If you had $20, and then all of a sudden you had 5 less, how many dollars would you have? So you had $20, but now you have 5 less. How much do you have? And everybody's going to tell me 15. You're all going to say 15. No one's going to miss that problem because you're all going to say 20 minus 5 is 15. Well, where does the 5 go? The 5 goes in the back. So just be careful there, right? 5 less, it's minus 5. All right, and then we have to deal with twice a number. How do you do twice something? You either have it 2 times or you multiply it times 2. So I can go n plus n, or I can do 2n, right? N plus n, which is 2n, or 2n. All right, 2n minus 5, and there we go. All right, C, next page in your notes there, 4 more than 1/5 of a number. So again, we're going to NTV, and the number we will call N. We're taking a look for those keywords, and so we have more than. We all know that that's a plus. So 4 more, so I'll stick my 4 there. Now what's left you have to think about is the aspect of 1/5. 1/5. All right, so let me do another analogy. Let's suppose you had 20. I will use money. It's easy. Let's suppose you had $20, and all of a sudden I said you just spent half your money. Everybody's going to say I have $10 left, right? You got $20, you spent half your money. What do you have left? 10. Well, how did you get 10? Oh, I did 20 divided by 2. All right, very good, right? You divide it by 2. That was 1/2 your money. If you had $20 and I said, oh, you only have 1/4 of your money left, I hope you're going to say you have $5 left. You're going to do 20 divided by 4. So how are we going to do 1/5? We're going to do n divided by 5. N divided by 5. So n over 5 plus 4. Now, by the way, if you had $20, half your money would be a half times 20. Same thing. A half times 20 is the same as 20 divided by 2. So if you wanted to, you could also write it this way. 1/5 n plus 4. Those are exactly the same thing. This is usually the preferred methodology there. Okay? All right, let's get to some special cases. So our first special case here that we're dealing with is in the aspect of consecutive numbers. All right, you got to think about that. So we're talking about stuff like, 11, 12, 13, 14, 37, 38, 39, etc. No big deal. All right, consecutive numbers. So we're going to call the first number n. We're going to call the first number n. Now, whenever I do this in class with the live audience, I ask, all right, so class, what do you want to call the second number? And you know what a lot of people tell me? They tell me y, or z, or x, or p, or d, or whatever their favorite variable is. And that's what they tell me. And though you could do that, you won't be able to solve the problem. So that's not going to help us. We need to name the second number in respect to the first number. And it's really simplistic, but let me get you to think here. Look inside my purple circle here. So look, this is hard. It's going to be difficult, right? Little mental math. I'm going to tell you a number. I want you to tell me the next number. Oh, this is hard. 77. 78. Yeah, that was not a trick question. Pretty simplistic. All right, here we go. Ready? 11. Next number. 12. Okay. So think about what you're doing there. Are you ready? First number's n. What's the second number? Did you get it? Did you get it? All right, some didn't, I know, because it happens all the time. So let me go back again. If I say 77, you say 78. What are you doing to get from 77 to 78? If I say 11, you say 12. How did you get from 11 to 12? Well, then if I say n, how do you get from n to the next number? And hopefully you caught on n plus 1, right? 77 plus 1, 78. 11 plus 1, 12. N plus 1, the next number. That's all we're doing. You follow? Pretty simplistic, all right? Nothing earth-shattering there. All right, well, let's now do the third number. So how are we going to get to this third number? So again, it has to be in respect to the first number. So now I'm going to give you a number, and I want you to not give me the next number, but the number after that. So I'm going to give you the first number. I want you to give me the third number. I give you the first, you give me the third. All right, here we go. 7. 9. You guys see, your brainiacs. You're amazing. All right, we can do this. It's pretty easy. 21. 23. Okay, so n. And you're thinking, and I hope you're thinking n plus 2, right? Because how'd you get from 7 to 9? You added 2. How did you get from 21 to 23? You added 2. Now you might say, no, I counted. Well, I know, but what is counting? To go from 7 to 9, you're adding 2. To go from 21 to 23, you're adding 2. So to go from n to the third number, you're adding 2. All right. So you're always going to name your variables that way if you have consecutive numbers. If you only have 2, it'll be n and n plus 1. If you have 3, it'll be n and n plus 1 and n plus 2. What if you had a fourth one? N plus 3, etc., etc., etc. All right, another situation, special situation, is consecutive odd or even numbers. Consecutive odd or even numbers. I mean, 1, 3, 5, 7, 9, 11, etc. Or, of course, the proverbial 2, 4, 6, 8, etc., etc. Believe it or not, these fall in the same category, whether it's consecutive odd or consecutive even, because in both cases you are counting by 2's, right? So we're going to name our variable. Again, we're going to call the first number n, and now we got to get to the second number. And again, it's the same situation. If I say a number, tell me the next consecutive odd number, all right? 13, and you all say 15. Amazing. 77, and you all say 79. All right, so then n. And now hopefully you're going to say n plus 2, right? How did you get from 13 to 15? 2 more. I say, Mr. Scarfy, that's consecutive odd. What if it were even? All right, if I gave you the number 18, the next even number is 20. Aren't you still adding 2 to the 18 to get to 20? Of course you are. Of course you are. So whether it's consecutive odd or consecutive even, if you want to get to that next number, you got to add 2. You have to add 2. All right, let's do the third number. So again, now you got to skip, right? So if I say 3, you're not going to say 5, you're going to say 7, right? 3, skip to 5, go to 7. If I say 20, you're not going to say 22, you're going to say 24. Got it? All right, so here we go. How about 34? And hopefully you said 38. So we're going to do odd or even, it doesn't matter. How about this? 91. And you said 95. All right, n. And hopefully by now it all makes sense, and you say n plus 4. How did you get from 34 to 38? You added 4. How did you get from 91 to 95? You add 4. How do you get to n to the third number? You add 4. Okay? There would be a fourth number. It'd be n plus 6. All right, let's do a couple more word problems and we'll be done. Write an expression for 2 more than twice the sum of 2 consecutive even numbers. All right, that may seem like a tough situation, but it's not really. So let's name our variable. So we have 2 consecutive even numbers. All right, 2 consecutive even numbers. So we have to have the first number and the second number. And remember, they're consecutive even numbers. So again, we already determined that whenever you have consecutive even or consecutive odd, the first number is n, and the second number is n plus 2. Okay, that part's done. Let's go back and start looking for keywords. 2 more than. All right, we know the more than. That's the plus sign. How much more? 2, right? We're adding 2. 2 more than twice, and then the sum of. Okay, there's a little bit here, so we got to be careful. Let's do the sum of. The sum is addition, correct? And what am I adding? The 2 consecutive even numbers, the n and the n plus 2. All right, let me let you look at that and let that sink in. So I just added, right here, that's the sum of 2 consecutive even numbers. Do you agree? N plus 2 is the sum of 2 consecutive even numbers. Yes? Now, how do you do twice something? You multiply it by 2, right? Now, let me get rid of the box and show you what most students will do. Here's what most students do. Is that true? Is that twice the sum of the number and its next consecutive even number? And the answer is no. But look, if the box were there, you want 2 times the box, don't you? So how do you do that mathematically? And hopefully you're saying, oh, I need a parentheses. There's that expression. Okay? A little tricky, but not too bad. A little tricky, but not too bad. All right, just take it one step at a time. All right, let's do F here. Write an expression for the sum of an angle times itself and its complement. Oh no. Angles. What in the world? How do we get to angles? Okay. Well, let's think through this thing. The sum of an angle times itself and its complement. Okay, so I need the angle. You want to stick with n? All right, we'll stick with n. Its complement. I'm going to abbreviate COMP. Its complement. Okay, I need to refresh your memories. So last year we talked about complementary angles and also supplementary angles. In both cases, they are 2 angles that add up to a certain amount of degrees. Do you remember which? So complementary angles are 2 angles that when you add them up, they add up to how many degrees? So let me show you the pictures, all right? Here were the pictures. Okay, so that's a picture of one of the sets, and that's the picture of the other set. Which ones were the complementary angles and which ones were the supplementary? Is number 1 complementary and 2 supplementary, or is number 1 supplementary and 2 complementary? Well, I put them in order. Number 1 is complementary and number 2 is supplementary. Number 1s add up to 90 degrees. Number 2 add up to 180 degrees. Okay, so let's play a little bit of analogy here. I'm going to tell you an angle. You tell me the number of degrees of its complement. If I said one angle was 50, you're going to say the other angle is, and I hope you're going to say 40. If I tell you one angle is 30, its complement is 60. If I say the one angle is 80, its complement would be 10. Now, how are you getting these values? You should have been doing this. 90 minus 50 is 40. 90 minus 30 is 60. 90 minus 80 is 10. Now, again, I know some of you are thinking, well, what 50 plus what number equals 90? But that's the same as 90 minus the number. So what would the complement be? And hopefully you say 90 minus n. All right, that's the hard part to the problem. If you get that, you're in good shape. Okay? So now let's just go back and put it into an algebraic expression. All right, we got the sum. So we're going to add. And what are we adding? The sum of an angle times itself. Angle times itself. Is that 2n or n times n? Angle times itself. Well, just do it. The angle times itself. Is 2n and n times n the same thing? And the answer is no. N times n is n squared. Now, let me just, for a second, this is the mistake students make, and I don't want you guys to make it. So, n squared, let's suppose n was a 5. 5 squared is 25. Is 2 times 5 the same as 5 squared? And the answer is no, right? They're not the same, so be careful. Don't get squared mixed up with double. All right, so the sum of an angle times itself and its complement, we already named its complement, 90 minus n. And there you go. We just turned it into an algebraic expression. If you wanted to clean it up, you could say n squared plus 90 minus n, and away you go. All right, remember, don't worry about your homework. We are going to work on it in class tomorrow. So quick recap. What's an algebraic expression? It's just some variables and or numbers. What do you do if you're told to evaluate? You have to sub in the values for the variables. Remember, put a parentheses in place of the variable. Leave all other things there. Sub into the parentheses. You'll be in great shape. If they give you a domain, it just means it's that many problems. Not a big deal. And then, of course, we went to translating. This is always the case for consecutive numbers. This is always the case for consecutive even or consecutive odd. Always. Remember those and you'll be in great shape. All right. Have a great night.